This is Rad Lazic for Engineered Efficiency. In this lesson, we will work in a drawing called vertical analysis. We will perform the ground cover and the ground conflict report from the swept paths panel, and then we'll perform vertical clearance analysis. In this example, I have created finished ground surface from the intersection model created with Civil 3D in this drawing and call it vertical analysis finished ground. Just like so many other roads, this one has a crown that runs through the intersection and a standard 2% cross grades away from the crown. If we zoom in, we can see that our design vehicle here is a special used vehicle for transporting large items. For that reason, it is an articulated vehicle and it has the very low ground clearance to accommodate the load. I have created the swept path through this intersection using the standard method, and I've also created a few insertions of the vehicle symbol. If I zoom into this area, you will see that in this particular case, the rear axles are on one side of the low grade on the side of the crown, and the rest of the axles are on the opposite low side of the crown, and the lowest part of the vehicle runs right across the crown of the road. Autodesk Vehicle Tracking has a tool to analyze and report the ground conflicts between this finished ground surface and the design vehicle. From the swept paths panel, I'll click on the Insert Ground Conflict Report, and I'll simply click on the swept path. It's asking me for existing surface and then final surface, which I will set to vertical analysis finished ground. When I click OK, we will proceed with default values and we'll see the results displayed in the plan view. Everywhere where this low part of the vehicle, or where the very low ground clearance will conflict with the finished ground, will have the conflict lines. Notice that we have a number of sections labeled A, B, and C that are showing us some views, section views. And then the circled numbers are defining the exact conflict that we have. In this case is in feet. So we have 0.13 feet conflict in section A. In section B we have 0.01, so it's very small, or it's in section C. In section B is also, but in section A it's very significant. So I can zoom into the area where those profiles are created automatically as part of the reporting, and then find that here's the section A and here's the 0.13 of a foot conflict. For our next exercise, we will analyze the vertical clearance. From the swept paths panel, click on vertical clearance. We will not use this long and low vehicle for that. We will use the standard California legal design vehicle. And all I need to do is simply zoom into a profile, click on it, and let software analyze. You'll see that our path has stopped right there at the bottom of that vertical curve. And if I go and redesign my Civil 3D profile, I can then rerun the vertical clearance with the design vehicle, click on that profile, and notice that now we have the vertical clearance required for this vertical analysis. That's all for this lesson. Thank you for watching.